Hi, and welcome to the fourth in a six-part series explaining how to quickly deploy a powerful, fast, and scalable data analytics solution using the free components of the Elastic Stack. Unless you're only looking to learn about Kibana, I encourage you to watch the previous videos if you haven't already. In the next two videos, we'll be diving into Kibana, Elastic's open source tool for analyzing Elasticsearch data. Now, Kibana itself is a sort of platform made up of multiple different sub-applications. The default free distribution contains a number of useful and full-featured apps, and we'll be focusing on those. We'll briefly discuss some of the paid add-ons offered by Elastic in the last video. So when you first go to Kibana, you'll be greeted with this sort of welcome page, and it provides some advice for how to get data in if you haven't already, as well as introduces some of the main apps available in the Kibana interface. Now, some of these won't be available if you don't have the paid subscription or if you haven't activated the trial, and we'll go into those in the last video in the series. In this case, we do already have data, so we can go straight over to Discover. Now, Discover is basically where you typically want to start to just sort of start exploring and understanding your data. It's like a Google-style interface in which you can search and explore the raw data contained in your Elasticsearch index. So right off the bat, we see basically an unfiltered view of our index and all the data in it. If you expand one of these rows, you can see all the fields and their values for this particular object. And you can even come over here and see the JSON representation. Now, all the data in the index is going to be filtered by a certain time range, and that's what your view is going to be limited to. And so that's really important to keep in mind, because on pretty much any of these interfaces, the time window that you've selected is going to filter everything that you see. So any searches you do, any filters you do are going to be limited to whatever this time range is. Now I have it set to 50 years because looking at climate data, we're looking at pretty long time ranges. Of course, if you're looking at more recent types of data, these defaults are going to be more applicable, where they're looking at, within the day and up to the last few years. But of course, you can specify whatever you want, and we'll even go back 150 years just to show how much climate history is in this database. It's going to take a little while. So now we've found like almost 25 million hits, and you can see that these are the counts of data points by year. And so you can see there's a lot of data being produced back in here, and then less more recently. I'm not sure why that is. Also available up here at the top in most of the views are some other options for what you can do with the page that you've configured. So new is just going to reset it with the default settings. Save is a way to save any settings that you've made so that you can easily retrieve them again. Open obviously would be a way to retrieve them, any saved Discover pages that you've created. And then share is really handy. So they have this link, which is essentially what's in the URL, and the URL is always representing the state of your view. So any filters you add, any columns in this case you add, are represented in the URL. But that makes the URL extremely long, and so it's handy that there's a built-in URL shortener right here, which you can just click and copy, and this URL is much easier to copy around. And again, that's going to save the state of your view to make it easy to share. And that's one of the biggest benefits, I think, of having a web-based analytics tool is how easy it is to share around. Anybody with a web browser can see what you're doing. And then there's also this option of reporting, which is if you save a view, like we talked about, you have the ability to generate a CSV containing all of the data in that view. And that's really handy for if you need to extend your analysis in a tool like Excel. You've also got auto refresh, which is just going to reload this page on some interval, which is handy for like live dashboards. You can also kind of create a table out of this view. So let's say we wanted to see the country these are coming from and also the temperature. Well, we can just add them like that, and now we have really easy access to those values. And we can just scroll through a bunch of history. This is an infinite scrolling interface, so the more you scroll down, the more data it'll load lazily. And then you can also really easily add filters from this table interface. So we haven't talked about how to kind of manually add filters, but an easy way to get started is to just use these little plus minus buttons. So let's say we just want to find data from the United States. We can hit plus, and as you can see, it added this filter up here for United States data. And in a moment, we've now got only United States information shown. So that's really handy. You can reorder these things, etc. All right, let's talk about the search interface because that's really important to master. Basically, any analysis you're going to do in Kibana is going to require understanding how to filter your data, and that's probably the biggest learning curve in using this tool, and the thing that you really need to figure out before you're going to be very effective. Now, at its most simplest, the search interface is a lot like Google or any other search engine. You can basically just type keywords, hit search, and it will search all your data for that keyword, because Elasticsearch actually indexes your string data by keyword separated by white space or punctuation, which makes it able to efficiently search for individual terms across all the objects in your data. So even though we had 25 million objects here, and I didn't even specify a field to search, it was able to quickly find the 11.6 million that contain the word states. Now, if I did want to be a little bit more efficient, and sometimes searching across all fields can be a bit slow, you can specify the field that you want to specifically filter on, and that should be a little bit faster. You can also do things like search for phrases with quotes. So country equals United States should return mostly the same number of hits. But it looks like the number actually went down, which is a little bit interesting. So I guess there's some other things that contain, some other countries that contain the word states. So let's see what those are. So if we add our original filter for states, and we say, but we don't want ones with United States, we can see what those other countries are. And there it is. Federated States of Micronesia was also getting picked up in our states filter. So that's a good reason to specify as much with as much clarity as you can. If, for example, we were just looking for United States, it's good to know that states is not a sufficient filter. This also points to the Boolean complexity that you can build out into a filter. So you can AND things together, you can use nots to negate, you can use parentheses to group and force an order of operations. So like if we wanted to say that, or I don't know why you do this search in particular, but so if for some reason you wanted to do a search that found the Russian Federation and Micronesia in this case, because that's the only thing with states but not United States, that this filter would give you that. All right, so some other things you can do. So if a value is indexed as a number, you can do comparisons. So let's say we wanted to find all temperatures which are greater than 20 degrees Celsius. And there we go. So we quickly found that 7.3 million of our hits are above 20 degrees Celsius. And again, you can combine that with all sorts of other filters. So that makes that's really a powerful interface. Now it's a little hard to get started with, and it has some sort of surprising requirements. For example, spaces are considered ORs, which is kind of like any other search engine, but you need to use capital AND for the Boolean operators, capital OR, etc. And it's a little picky about some of the syntax. Like, because spaces are ORs, you can't say country states. That's going to search for the term country or the term states across all fields. So you need to make sure there's no space in there. So it's a little finicky. And so they actually came out recently with a new query syntax that's a little more user-friendly. And it actually also has autocomplete, which is really awesome. So I can start just typing a field name, and it'll show me the fields by that name that I can choose from. So let's say we want to search for country, and it also doesn't care about spaces. So I can say country states now, and it should do the same thing that my previous filter did. And so what's nice about this is it's similar to the old Lucene syntax. So if you were used to that, it's not too hard to get up and running, but it's not as picky. So like underscore and, lowercase and rather, is correct or fine. You can also do uppercase, that works as well. And again, it gives you these nice little hints for how to build up a filter. So anyway, it's pretty cool. You can start with either one. Once you've learned one, you probably don't need to go back and forth too much, but the autocomplete capabilities of the new syntax is pretty handy. All right, so I cleared it out again. I also want to talk about the difference between the normal field and the keyword field. So by default, all text is indexed according the way I mentioned, where it basically breaks it up into terms separated by white space or punctuation. And that's great if you're looking for word or simple phrases across a lot of fields. But if you want to find a specific string of text that might contain punctuation and spaces, and you really want to be explicit about what you're looking for, the keyword field is the appropriate choice in that case. And the other nice thing about the keyword field is because it just stores a single value rather than a bunch of terms, it can do autocomplete and make recommendations about the values. Now it doesn't give you a whole lot of options here. There's obviously more countries than these, but it looks like it's giving us the most significant in terms of volume perhaps, so that's pretty cool. So if we were looking for United States of America, we could go ahead and do this and hit enter, and it would find those hits. So one thing to keep in mind with the keyword field is that unlike the normal field, it is case sensitive. So if I search for China lowercase, it's not going to find anything. I have to be case sensitive there. So that's something to keep in mind. Another thing to know is that both the keyword and the normal fields support wildcards. So in the keyword case, searching for states here is not going to work because there's no country whose value is states. But I can surround it with asterisks, and now I'll find anything containing states, kind of like what we did earlier. Similarly, if I wanted to find things using the normal field containing the term state, which I would want to hit find states as well, I can include an asterisk in the field or the value itself. And so state asterisk found states. So that's pretty handy as well. One final thing I'll point out here is that this isn't so relevant in this data set because pretty much all of our objects have the same fields, but you can also very quickly find out if a field exists by just doing : asterisk. And so that's a nice way to filter your data. If you have different object types, for example, and you want to find objects that have a certain field, this is an easy way to do that. All right, let's talk a little bit about this add a filter button now. So the add a filter button is just a different way to filter your data. So if you don't want to type in, a long string of filters with ands and ors, you can do the same thing using this add a filter interface. And what's nice about this is it right off the bat gives you a list of all the fields that you can choose from. So I can, quickly find country. Again, it lets you choose between the keyword and the regular version of that field. And it gives you all the options that you have for the Boolean operators, which is handy as well. And then, of course, you can add the same values that we added before. If you use the keyword field, you also get autocomplete, though the list of options that it gives you is not everything, so it is pretty limited there. So this is handy. You can also give it a nicer label than what it would normally choose. So we'll just say, for simplicity, China. So now let's filter everything by country as China. And that worked just like it would have if we had typed the filter in. So this is a nice way to sort of have default filters. So like I could create a bunch of these filters, I could save this, and then this could be my starting point, and then I could add additional filters on top of these using the normal search syntax up here, which is pretty sweet. You also, like I mentioned, have the ability to enable or disable with just a checkbox, and it still keeps that filter configured. So if I want to go back to filtering on China, I can do that really easily. You can also quickly negate. So let's say we want everything but China. I can enable this again, and I could say negate, and that's a really easy way to find everything that's not China. I didn't mention it before, but that little animation at the top is what tells you that the page is still loading. So again, you can continue adding filters here, and it'll just build a view out of that. So it's pretty slick. It's also got some bulk options if you want to just kill them all at once or invert everything, etc. So that filter interface is pretty handy. And then you can change them after you've created them. Another thing that's really powerful about these filter buttons is you can actually enter the JSON from the Elasticsearch query domain-specific language in here as well. So even if there's some capabilities that Elasticsearch filters have that are not exposed in the UI or in the Lucene syntax or whatever, you can actually build up your own complex JSON query pattern right in this filter, give it a name, save it, and that's a good way to extend the filtering capabilities beyond what might be easy in the UI itself. Now, while Discover gives us a nice view into the raw data, the real power of an analytics tool is the ability to draw insights from large data sets through aggregations. For that, we need to use the Visualize tab. So to begin with, we don't have any visuals saved, so there's nothing listed here, but if we did have some saved visuals, you'd be able to pick from them and quickly search through them if you have a bunch to find an existing visualization. But since we don't have any, we're going to go ahead and create one. Now there's a bunch of different types of visuals you can create, and in this video we're going to be focusing on a few of the core ones that you'll probably use for most analysis. But there's a number of more advanced and less polished visuals that you can use to sort of extend the capabilities of Kibana, and we'll be going over those a little bit in the next video. So since our data is climate data, it's sort of inherently time series based, and so these XY charts are going to be useful for that. So vertical bar, line, area especially are going to be useful ways to visualize this type of information. So let's just look at a line chart. And we'll pick our index. And by default, we just have a single data point for a single bucket, which is everything. And it's showing the count of objects in our database, which is 25 million. Now before we get anywhere, I want to go ahead and filter this on just the average temperatures. So the database that we're looking at is climate data, and it is storing averages, mins, and maxes for the month for all the different temperature stations in the database as separate objects. And so if we look at everything together, we're going to see a mixture of averages, mins, and maxes, which, if there aren't the same number of mins and maxes, for example, could throw off our numbers a bit. So let's focus just on average temperatures for now. And let's go ahead and add a date bucketing to our x-axis. So basically, before any of these graphs are going to be very useful, you're going to have to pick a bucketing aggregation, of which there's a number of different choices. Date histogram is a common one for time series data. Terms aggregations is one we'll look at in a little bit. It's basically a way to group by the values of a particular field. And yeah, there's some other interesting ones. But let's go ahead and look at the date histogram. So because I chose an auto interval, we're going to see a bucket for every year, since we have a 150-year interval. So it chose a yearly bucket, which makes sense. And we're still just seeing the count of objects, so the count of average measurements essentially for every year, which isn't that useful. What we really want to probably do is trend things like the average temperature. So let's go ahead and do that. We'll say average temperature instead of count is going to be our new y value. So let's run that. And now what we've done is we have averaged for every year the average temperatures for all temperature stations for the last 150 years, and we've trended that. And that's pretty remarkable how quickly that ran, especially considering this is still just running on a VM on my PC. Not a cluster, nothing like that. Okay, so about, I guess, what we'd expect. Temperatures have been increasing over the last 150 years. If we want to smooth this out a little bit, what we could do is we could add a moving average. So there's a number of different sort of second order aggregations available. Moving average is a good one for this. And again, we'll have to tell it to do the average of the temperature, and we'll hit run. And so now we have overlaid a smoother moving average line that does a little bit to smooth out some of the year-to-year variation inherent in climate data. All right, this looks pretty good. Let's make these labels a little bit better. So we can do that just by setting a custom label here. So let's call that average temp. We'll call this move average temp. And we'll hit play. And these labels should update. And let's save this one. So temp trend. Cool. So that's just a quick way we can kind of start visualizing this. Now this is for the entire globe. So if we wanted to, say, just look at the United States, that's quite easy. Just as we saw before, you can just add a filter for that. And now this is just the United States. All right, so let's clear this out. Come back to visualize, and let's look at a different type of visual. So another thing I wanted to look at was if we had the same number of measurements for averages, mins, and maxes. You'd kind of expect that, but if we don't, that would be a good reason not to mix those values when doing sort of high-level analysis. So to do something like this, we can do a bar chart, and we're going to pick for our x-axis aggregation this time a terms aggregation. And we're going to tell it to choose the element, which is t-average, t-min, or t-max, and we're going to leave it at, let's see, at showing a count. So we want to see if we have a different number of measurements for these different metrics in our database. And we'll hit run. And we can see that we actually do have many more averages than mins and maxes, which is not as concerning as it would be if we had many more mins or maxes. That's what would really throw our metrics off. They are different, but not too much. So anyway, that's just interesting. Looks like averages maybe were measured over time more than the others, which we could actually measure that as well. So let's do that. All right, so for our x-axis, we're going to switch over to a date histogram like we had before. Go ahead and plot that real quick. All right, and now we're going to do a split series, and this time we're going to split it on the element term like we looked at just a minute ago, and we'll hit run. And so this is going to basically split up these counts by the metric that we were measuring. And we can see that indeed it looks like the average, way back in the day, averages is all that was typically measured. And then over time they started capturing mins and maxes pretty consistently. So that kind of explains why we have so many more averages than mins and maxes. It's just a more common metric to measure, which makes sense. Okay, so that's a little bit of quick analysis with some time series visuals. Pie charts work the same way. Obviously, you don't have quite as much, you can't show quite as much. But if we wanted to show that same thing, for example, with elements, we could do that and say, plot that real quick. So that's just a simple pie chart showing counts, and it also shows percentages on the tooltip, which is handy. But you can actually add additional bucketing or break these slices down further with a sub-bucket. And so let's say we want to find like the top countries for each measurement. So we can come in here, pick terms aggregation by country, and since it's going to get tough if we show too many things, we're just going to show 10, ordered by the count of the measurements. So this is going to be sort of the countries we have the most data for each type of measurement. And so here we can see that the US is the biggest one, followed by Canada, then Australia looks like, and that pattern sort of is consistent for all the measurements, which isn't surprising. So anyway, just some different ways you can build upon these pie charts and build a pretty complex thing. And you can even go further than 2. You can keep building up and keep having sub buckets on each of these slices, which is pretty slick. If you prefer, a more traditional rendering, you can do that, of course, which is something to keep in mind. The default styles and stuff of these charts, there's a lot of configuration options you can tweak by going into the options tab. And when you're looking at time series, there's a number of configuration options as well for like how the different axes are rendered, and whether they're you have a stacked chart or not. You've got a bunch of different options for that. So definitely explore this. You can usually customize pretty heavily what you want to do. You can change from linear scales to logarithmic, all kinds of stuff. So the next type of visual I want to talk about is the data table. Now the data table is a really flexible one. So rather than trending something over time, this is really good for enumerating the actual values in a field and some metric for those values. So for example, if we wanted to find out what are all the countries that we have in our data set, well, from what we've seen so far, there hasn't been a good way to determine that. But if we do a terms aggregation on the country, and we bump up the size of the values that it's going to return to something plenty large in this case, and we hit run, now we have an ordered list of all the countries in this data set. And we can change the metric, of course. as before, we could instead pick the average temperature and run that, and now we'll have an ordered list ordered by the average temperature. So that's pretty cool. So we can also add additional metrics. So rather than just having 2 columns, we can have many more columns. And let's say we want to do a max temperature and a min temperature. So we can do that really easily and just add a couple columns for those other values. Now, of course, here, as before, we're looking at all temperatures, so that might be a little bit misleading. Let's only look at the temperature averages and make sure that that's what we're looking at. So what we've got measured now is the average temperature over all the last 150 years for this country, and then the maximum average for all months of all years during this time span, and then the min. All right, let's show a little bit more data at a time just to not have to page through quite so often. And rather than ordering by temperatures, let's go back to ordering by the name of the country. So I'll use term, so it'll now order it by the term. And defaulted to descending, we'll change that to ascending. Okay, so now we have an alphabetized list of all countries with their temperature metrics. Let's say we want to break these down a little bit further by, let's say, the names of the stations for each country. So this could get a bit large, so we'll see how this goes. We'll use a terms aggregation on the, let's see, the name, which is like the name of the station, and hit run. So this is going to take a while, especially because we're looking at all countries. And we'll bump this up to a lot, since some of these countries probably have a lot of stations. So there's a bunch of stations in Algeria, it looks like, not so many in Afghanistan. And if we go down toward the bottom, we can find the US eventually. Here we go. And so here's a bunch of the stations in the US. And there's probably more than 50 in the US, so we're probably getting limited by the fact that we selected 500 here. So if we wanted to say just the US, let's do and country United States of America. And we'll now bump, we can get rid of the country terms aggregation because that's redundant at this point. And we'll bump this guy up to 500 so we can get a full list of all of the stations in the US. So you can build up a pretty complex table using this visual. And you can also, and this is true for any of the visuals, you can actually export all of the data in the table to a CSV file so you can do further, more flexible analysis in a tool like Excel. So the last thing I want to talk about is the coordinate map. So there's a couple types of maps in Kibana. The coordinate map comes out of the box pre-configured to show latitudes and longitudes on a map. So that's pretty useful for data like this where we actually have that data in our data. So let's pick the location, which we've already mapped into Elasticsearch as a location. And we'll go ahead and hit run. And it's now going to plot our data according to location all throughout the world. And if we zoom in, we can see that each of these points is showing us the count of objects at that point. And it took a moment to refresh, but as you zoom in, the precision increases. So we're actually now visually seeing all of the different stations in the US. And if we zoom in further, we might see that there's even more than this. So basically sources of the data throughout the United States. And then each of the circles is showing us how many counts or how many measurements have come from that location. So let's do this again. Let's instead look at the temperatures like we did before, and we should see, and we'll use the temperature Fahrenheit again. And now we're going to show it by the average temperatures, and you can see, as you'd expect, much warmer temperatures in the south, cooler average temperatures in the north. And so this is kind of nifty. You can now zoom back and we can get a nice visual indication around the world of sort of average temperatures, and you might see some anomalies at different points based on geography or proximity to water or something like that. But anyway, so this is just an example of another way that you can visualize data in Kibana if you have it mapped out geographically. So the last thing I wanted to show in this video is how to create a dashboard. So this is really pretty trivial once you've created a bunch of visuals. So you just come into the dashboard interface, you click Add, and it'll list all of the saved visualizations that you've created. And you can even use save searches as well, which is what you would do on the Discover interface. So let's go ahead and just pick all the visuals that we've created. We'll close the Add section, and it's going to take a little while to load because it's going to load each of these independently because they could be showing totally different data sets. But once this loads, you'll see that we have a nice kind of way to quickly digest a number of different forms of analysis in one place. And you have all the normal dashboard editing capabilities. You can stretch these things around, you can reorder, drag and drop the different grid items on the grid. It's pretty powerful in terms of dashboard builder. You've got some minimal options for how it looks. You can remove the margins, you can give it a dark theme, which is kind of nice, etc. You can also hide the panel titles, or you can also customize those panel titles so that they don't simply show whatever you saved as the name. You can come up with something different. So that's all pretty nifty. The other cool thing about dashboards is any filter that is applied at the dashboard level applies to everything. And so, like, let's say we wanted to see a bunch of analysis for just the United States all at once. Well, rather than have to go into each of these visuals and modify their filters to only show United States, we can simply apply that to the dashboard, and all of the visuals on that dashboard will apply that same filter. And so you can see now we're just seeing geographic dates or temperatures for the US. All of this data is now filtered on the US, etc. And our temperature trend changed to reflect the US data. So that's useful. Another thing that's kind of cool is some of these visuals, if you click on something, it'll actually apply that filter to everything. So for example, if we wanted to say only show the t-averages, I can click on this and hit the plus button, and that'll add a dashboard-wide filter on t-averages. And so now we've filtered everything on that metric as well. And if we get rid of that, we'll go back to showing the old data. So dashboards are also a little bit unique in the sense that they have sort of an edit mode as well as a general consumption, like live mode. So if we hit save, we're now in sort of the live view. So you no longer have that little gear configuration option, and you can't drag them around or anything like that. You can, however, still manipulate filters. So if you share a dashboard and you want your users to be able to interact with that dashboard, they can without actually going into the edit interface, which is kind of neat. So it sort of separates the concept of configuring a view with filters versus actually reconfiguring the dashboard itself and the layout and things like that. So that's pretty neat. Also, once you've saved a dashboard and you hit share, in addition to the normal options that you have where you save a snapshot, you can save a link to the saved dashboard. And that's typically what you probably want to do when sharing these around, so that people always get your latest changes. If you only share the snapshot, you're only going to get the dashboard as it was configured at the time that it was shared. Whereas if you share the link to the saved object, they'll always see whatever your latest dashboard is. There's also a nice way to embed these things as iframes, and when you do that, it actually gets rid of all this extra chrome around the top. So you just see the dashboard itself. So that's very useful as well. At this point, we've gone over the core discovery and visualization capabilities of Kibana. In the next video, we're going to take a look at some of the more advanced features which aren't quite as simple to use, but which let you extend these capabilities quite a bit further.